All right. So what we're going to do today, we're going to go through the introduction. So we're going to start with chapter 1. We're going to start with section 1.1. We're going to talk about the introduction, so kind of what is stats or some key vocabulary terms we're going to need. And then we're going to get into the first part of statistical analysis, which is making graphs. Okay, that's a huge part of analysis with stats, is making graphs and being able to present the material to people in a way that they can understand pretty simply. Okay, so we're going to talk about 3 types of graphical displays today: bar graphs, pie charts, and frequency tables. So before we get to that, we're going to start with just some kind of key terms for vocabulary, or for stats. Now this you don't need to write down necessarily. So data, statistics is the science of data. Statistics is all about taking a set of data and compiling it, putting it together, analyzing it in such a way that it becomes useful for the people who need to look at it. So what are we trying to get out of this data? Stats takes care of all of that. So we can get pictures from it, we can get trends, we can get whatever we need to as far as what we're trying to analyze for that set. Okay?
Some guidance. And then Ben's down too.
Okay, perfect. So, first vocab word, individuals. So any set of data is going to contain information about a group of individuals. The individuals are the objects, and it can be people, it can be animals, it can be things that are described by the data set. So they are the objects that are described by the data set. Okay. Sometimes, depending on the stats book you look at, depending on the website you're on, they might refer to this as the who. Who are we studying in this particular instance? Okay. Now, the key thing to remember here, it says the who, it says individuals. Now when we think individuals, most often we think of people only. But this can be animals, it can also be things, objects, that are considered the individuals or the who of what we're studying. So the first thing you always want to ask yourself when you're looking at a set of data, who or what was actually being studied? What are the individuals that we're looking at or interested in? Okay. The next one are the variables, the next important part. Once you've identified who's being studied, you need to figure out what is being studied. Okay, so what are we actually measuring for these individuals? So when we talk about what we're measuring, we're talking about variables. Now variables for you guys up until now have pretty much just been X, Y, Z, and just different representations for numbers, right? When we talk about it in stats here, we're talking about a characteristic that we measure on an individual. So what are we actually asking or recording for that particular individual in question? Okay? By its name, variables, just like in algebra, change. So each individual might have a completely different response or a completely different measurement than another. That's why they're called variables. They can change depending on the individual that you happen to be looking at that time. Variables are often referred to as the what. So you have who. Who are you actually studying? The what do you need to know about them? Okay, so what do you know about them? What's in the data set that's allowing you to get some information? Okay with that? Okay. Variables take on 2 forms. Okay, you've got categorical variables. What's another name for categorical? Have you guys seen maybe a science and things like that? You might have dealt with like quantitative data and qualitative data. Anybody heard that term before? Okay, so categorical variables also can be called qualitative variables, but for the most part we stick to this term just because it's easier to remember exactly what we're talking about. So categorical variables place an individual into one of several groups or categories. Okay? So for example, you got gender, so that's a variable we can measure. We look at the individual and they're male or they're female. Okay? So there's 2 different categories. and then you fit into. Grade level. Okay, so grade level, if we're talking a high school setting, that could be 9th grade, 10th grade, 11th grade, 12th grade. So each class is a different group or category that you can classify individuals into. Grade. You could look at grades like you get an A, you get a B, you get a C, you get a D, you get an F. So each group you can place students into depending on their grade in the class. Okay? So categorical variables when you can actually set up separate categories and fit the individuals into each of those different categories. The second type of variable are called quantitative variables. Quantitative variables take numerical values, and generally the way that you can tell if you have quantitative data is if it would make sense to find an average with the data that you're looking at. Okay, would it make sense to find an average? Could you add up all the numbers, calculate an average, and have it mean something for what you're looking at? Okay, so GPA. GPA is a grade point average. It would be a numerical value that we would associate with each individual, but as far as comparing GPAs, usually we deal with them numerically. We would take their average, or we would take some of the classes and so on. Weight. One of the other things to kind of keep in mind here, quantitative variables almost always have some sort of unit of measurement. Okay? If it has a unit of measurement with the variable, that is a quantitative variable. We are treating that as numeric. We are dealing with numbers. That's going to be quantitative. Okay? So GPA, weight, grade. Now, what do we know there? Where else did we use grade? As a categorical variable. You get an A, you get a B, you get a C, D, F, right? How could grade be a quantitative as well? If you look at the percentages. So if you look at a class average, you treated those individual grades as quantitative data. So we took all of the individuals in the class, we added up their grades, divided by the total number, we found their average. That's quantitative data. But if we wanted to fit them into categories by A's, B's, C's, and so on, that makes it categorical. So one of the things you have to ask yourself when you're identifying the variables is how are we using it? Are we using it as a number, or are we using it as a category to classify individuals? Okay? So there are times where variables can be either one, depending on how you use it. Does that make sense? Okay? Again, the big thing here, units of measure are very big giveaways that we are dealing with quantitative as opposed to categorical. Okay? So numbers, big thing, but numbers are not always quantitative. There are times where we can have numbers as a categorical. For instance, back in my day, okay, our grades, depending on the district you were in, weren't A's, B's, C's, D's, and F's. They were 1s, 2s, 3s, 4s, and 5s. So even though we're dealing with numbers, like if I had a 1 in the class, that really meant I had an A, that's a category. We wouldn't use that 1 numerically as far as averaging or anything like that. We'd be using that as a classification. So numbers can be categorical as well. It just depends on how you're using them. Okay? The other thing to keep in mind, and this will make more sense when we get to like histograms and some of the displays that we're going to talk about next week, or possibly Friday, we can take quantitative variables and we can force them into the categorical variable idea. If we look at grades, so we know categorically we can make it A's, B's, C's, and D's, and so on. But if we were looking at class averages, we can also make that categorical by saying you're in the 90 to 100 range, you're in the 80 to 90 range, the 70 to 80 range, and so on. We are using it quantitatively, but by making a range of values, we are creating categories that we're placing individuals into. Does that kind of make sense? So there are times where we can take a quantitative variable and make it categorical by creating ranges of values. And we'll see that happen with histograms and things like that. Okay. So, quick example to make sure you guys can identify individuals, identify variables, and what type they are. Jake's a car buff, wants to find out more about the vehicles that students at his school drive. He goes to the parking lot and records some data. Later, he does some research about each model of car. Finally, Jake makes a spreadsheet that includes the car's model, year, color, number of cylinders, gas mileage, weight, and whether it has a navigational system. Okay? So he records all of this information about the cars that he observed in the student parking lot. So, given this scenario, who are the individuals that Jake is studying? Cars. Okay? So the individuals are the cars. That's what he's physically studying. Okay? So remember, who doesn't always mean people. It can be objects as well. So our cars are our individuals. Now the next thing you'd want to be able to identify is what variables were measured and what type of variable would they be. Okay? So let's just take that together. Let's name the variables and classify them as categorical or quantitative. So what is one variable that Jake measured? Okay, he measured the model. Each car he observed, he noted what model it was. If we're talking about models of cars, what type of variable would that be? Categorical. We have categories that we're fitting into. Okay, so car model, variable 1, categorical. What's another one? The weight. So we measured the weight or looked at the weight of the vehicle. Weight would probably be what type of variable? Quantitative. Okay, it's going to have a unit of measure. We're going to be dealing with weight numerically, so it would be quantitative. We also have gas mileage. Gas mileage would probably be quantitative. Okay. We have number of cylinders. What would number of cylinders be? What do you think? Quantitative? So quantitative in what way? What would you measure if you were going to use it as quantitative? Okay, so maybe 4, 6, 8. Now, if we're going to say quantitative, we need to be able to fit it. We need to talk about using it numerically, right? So if I was looking at like 4-cylinder cars, 6-cylinder, 8-cylinder, and so on, I'd actually be creating what? Categories. So if we're looking at just how, like, what cars were 4-cylinder, what cars were 6-cylinder, we'd actually be treating that like a categorical variable. But what he might be interested in, after looking through the cars, what is the average number of cylinders? So if he were looking at the average number of cylinders, then he's making that variable what type? Quantitative. Now he's actually adding up each of the cylinder numbers, dividing and getting the average. So this is one you could actually classify either way, depending on the way you look at it. Okay? Color, categorical, year, could really be either. We could fit it into categories. We could say like it's made from 80 to 85, 85 to 90, and so on, fit it into categories like that. Or we might want the average year. What's the average year that these cars were made throughout the parking lot? Okay? And then the last one, whether it has a navigation system, categorical. So yes or no fits into one of those categories. Okay? So one of the things you'll be expected to do is take a scenario like this and be able to say, what are my individuals, what am I measuring, and then what type of measurements am I taking? Does that make sense? All right. Distribution. Like we talked about earlier, variables generally vary. Okay, they're going to change from individual to individual. The distribution, and this is what we're going to spend almost our entire year studying, are distributions. A distribution tells us which values that the variables can take and how often it takes those values. Okay. So it's kind of an example here. So the distribution, let's say we're looking at the grade distribution in this class. So let's say this row has all A's, this row B's, C's, and then D's, okay? So if I were looking at the distribution of grades in this particular class, I would need to look at what values I can have. So what variable I was looking at, which is grade, what values can those grades take? What are the different values that I have created for my grades? A, B, C, and D, right? And we need to know how often the individuals take on those particular values. So how many A's would we have in our distribution? 4. How many B's? 5. C's? 4. D's? 4, right? So the distribution is all of that information put together. What values does my variable take, and how often does it take those values? Okay? And that's what we're going to be dealing with. That's what we're going to figure out how to graph or make a picture of, are these distributions. What does the distribution look like? And then from there, what can we say about it? Okay, that's the whole goal. The last one, inference. This is like the goal of statistics. With statistics, what it boils down to is we take samples. We take little pictures, snapshots of an entire population. We gather information on that little snapshot, and we get the information we need for that sample. Now, we can always say, with this sample, this is exactly what we know. But like I said, we're getting a snapshot of a little area of an entire population. We want to know what the population looks like. So we're going to take the information we find from our little sample and infer what can we say about the population then from what I gathered on this sample. So most of what we're going to be dealing with, and this is going to happen a lot in the second semester particularly, is inference. What can we infer about our population based on what we collected? Okay? So okay with all of that? Okay, that's kind of the main vocabulary for today. It's just kind of these main words. They're going to pop up over and over and over throughout the year, so we need to make sure right now we kind of know what's going on. The 3 rules of data analysis. Do not write these down. Okay, they're going to be very simple to remember. Rule number 1, you need to make a picture of your data. Okay, once you've collected your information, you need to put it into a picture. People don't like looking at lists of numbers particularly. Okay, they like visuals, they like pictures, things they can see trends on, and so on. Okay, so we always want to make sure we have a picture. They're going to reveal things that might not be evident in just a list of numbers. We can start seeing patterns, we can start seeing trends. Rule number 2, make a picture. Take your data, make a picture of it. Bar graph, pie chart, histogram, whatever. We'll talk about a lot of different types. Okay? Important features and patterns show up. What do you suppose the 3rd rule is? Make a picture. Okay? People like pictures. When you report data to other people, they want to see pictures. They understand pictures better than they understand lists of numbers. Okay? So every time we ask you to analyze a set of data, more often than not, they're going to ask for some type of graphical display. Take this information and make it presentable. Tell us what it means in a picture so that people can see kind of what's going on. Okay? So, first type of graphical display. Now, as far as presenting data, this is not always the best choice. If you have just a few categories that you're working with, so this is going to be with categorical data. Okay, so that's one thing you might want to note on here. Frequency tables are for categorical data. if you have a bunch of categories, these are not going to be the best choices as far as a graphical display, because then you're basically making a chart of numbers, which isn't very visually stimulating to people trying to read it. Okay? But if there's not too many, and all we really care about are the numbers, the counts, and things like that, then it's not too bad to use. So with a frequency table, we are going to pile the data. So we're going to be counting the number of data values in each category of interest. So in our class example, we would have a category for A's, B's, C's, and D's. Those were our grade level distribution. So we would keep track of how many A's, how many B's, how many C's, how many D's, and just put it into a chart. A's, 4. B's, 5. C's, 4. D's, 4. Okay? So a frequency table is literally just a chart with counts for each category. Okay? So we call them counts when we take the number of individuals within a category. And then the frequency table records the totals. How many total individuals fit into category 1, how many total fit into category 2, and so on. Okay? And remember, if I go too fast on this, you can let me know and I can slow down, or you can always go back online and get some of this information a little bit later. So here's what a frequency table can look like. Okay? So in a frequency table, what we're looking at here, this is an example from your book, they wanted to look at radio stations throughout the U.S. and just kind of see what type of music are they playing. So what are the radio stations across this country? What are they playing overall? Okay? So the individuals in the study would be the radio stations. So each radio station we measured a variable for. What variable are we measuring as far as the radio station? What do we want to know about the radio station?
What they're putting on their station.
What type of music they play. So what type of radio station are they? Are they rock? Are they country? Are they reggae? Are they jazz? Whatever. Okay? So they're always going to tell you what the variable is in the frequency table. What variable are we measuring? Okay? So in this case, they're measuring the format. What type of music are they playing? Within that variable, then, you have your categories, your values. These are the different types of radio stations that they found: adult contemporary, adult standard, contemporary hit, country, and so on. Okay? In the right-hand column, then, you have the counts. This is how many radio stations played each of these types of music. So there were 1,556 radio stations in the country that play adult contemporary. There are 869 that play rock. So in that right column, they keep track of the counts. How many stations fit into each of the categories specified? Okay? So this is your generic frequency table. A list of the categories and a list of the counts that go with each of those categories. Pretty straightforward. Okay? This second table that we see here is called a relative frequency table. This is one that you want to make sure you write down. A relative frequency table does the exact same thing a frequency table does, but it measures percentages rather than counts. So a relative frequency table measures percentages, not counts. Okay? And that's a pretty good rule of thumb overall. Relative frequency. Anytime you see that term being used with anything, relative frequency means percentages. We're always talking percentages or proportions when dealing with relative frequency. Okay? So when we look at this relative frequency table, we still have all the same categories we had before. We're still measuring those categories for the variable, but now we're looking at percentages. So adult contemporary had 1,556 total stations that played that. Well, if we take that 1556 and divide by our 13,838 total radio stations, we find that 11.2% of radio stations play adult contemporary. Okay? So rather than counts, we can keep track of the percentages for our overall set of data. And a lot of times, this would probably be the way I would go about it. As far as people reading information, people tend to like percentages much better than they like just lists of numbers. Percentages they understand. 11.2% means more to people than 1,556 total stations. Okay, so they can kind of tell that's about how many of the whole play that particular type. Okay, so frequency table, that's all there is to it. List your categories, find the totals, or find the percentages for each category, list them in a table. Okay, pretty straightforward. Frequency tables, though, like we just said, can be difficult to read. If we were looking at this and we placed a frequency table down in front of you like this and said, hey, find the pattern, you wouldn't really do a very good job of it, or it would take you a long time to kind of figure out exactly what's going on. Okay? So frequency tables, especially when we get to large numbers of categories, aren't the best option as far as displaying the data that we're looking at. Okay? So the better options, the more visual options, would be like your bar graph on the left or your pie chart on the right. Okay? So the bar graph does the exact same thing a frequency table does, it just does it visually. So we have all of our categories along the x-axis, and then we have our counts represented by a bar on the graph. Okay, so 1,556 categories for adult contemporary, boom, however many the adult standards, and so on. Now it's easier to compare some of the different categories. For instance, what is the highest number of a particular category? What type of station is the most prevalent throughout the country? News and talk. So news and talk shows are the most prevalent. They have the highest number of stations that play that type of programming. Okay, what's the least? Contemporary hit. Okay, so the least number of stations play that type of music and so on. So it's a little bit easier to kind of see those types of things when it's graphically displayed this way. Pie chart. Pie charts do the same thing, except they put it into a circular graph, and they just deal with percentages. So basically, it's like a relative frequency. Okay, so they calculate the percentages, create the wedges that result from that, and they can display it that way. You can see which wedges are bigger or smaller, and so on. Okay, so that's kind of what we're going to be dealing with next here. For a bar graph, have you guys dealt with bar graphs and pie charts before? For the most part, so a lot of this should be review for you. We'll just kind of touch on some things that we need to have happen every time you do bar graphs and pie charts. But a bar graph displays a distribution for a categorical variable. That's the one thing I need you to get from that. Bar graphs only work for categorical variables. And what they're very good at is allowing us to compare different categories to one another. They're very easy to look at, they're very easy to read, they're very easy for comparison. Okay? So bar graphs are always used when categorical variables are in play. So the frequency table here is an example that came from my old book. It dealt with the Titanic. So they broke the Titanic down into the types of passengers that were on board. So there was first class passengers, second class, third class, and then crew members. So here are the counts for each of the different classes on the Titanic at the time that it was sailing. Okay? So if I wanted to create a bar graph of this information, the first thing you need, so creating a bar graph, you have to create axes. So you have to have an X and a Y axis created every time. Okay? As soon as that happens, the very first thing you should always do, because if you leave these off, you will lose points on quizzes, tests, on the AP exam. Once you have your axes drawn, you must title and you must label your bar graph. So you have to come up with a title for your graph so that people, based on the title alone, know what they're looking at. So the title here could be People on the Titanic by ticket class. People see that title, they know those bars represent the number of people by class on the Titanic. So it doesn't have to be a full sentence, it doesn't have to be anything really drawn out, just something that gets the general gist across. What are we looking at in the table here? Labeling. You have to label your axes every time. Okay? So generally, you're going to put your variable along the x-axis. What is the variable we measured? In this case, it was class. What class did a particular individual fall into? Okay? The y-axis, then, is going to be your frequency, or your counts. How many people were in each of these different classes. Okay? Next thing, you need to create scales for your counts. Okay? So you need to figure out basically what numbers you're dealing with, find your minimum, find your maximum, make sure your scale ranges the entire set of data. You have enough space to put the lowest value up to the highest value. So here I chose to go by 200s up to 1,000. That way I know I had all of my categories covered. And then from there, just draw your bars. So first class passengers, there were 325, so I'm going to have the bar up to about 325. Go to second class, 285. Third class, 706. And then crew members, 885. So once you have your title, you have your labels, you have your scale along the y-axis, it's just creating the bars. Now when I'm asking you guys to do this in the homework, I don't expect you guys to get out rulers and everything and make everything exactly perfect and measure it all out. Even on quizzes and tests, just do the best you can to stay neat. Okay? Try to make sure that your bars do match up with the numbers that they're representing, so don't like put the first class above 400 when we know it's less than 400. Okay? So just be real careful with how you're doing things like that, and then just make it as neat as possible. I don't expect you guys to take rulers and all that stuff, make it perfectly nice and neat. The other thing is when you're creating your bars, and this kind of goes into the neatness category, just try to keep them the same width. Okay? We don't want width of bars to start playing into how we perceive the size of a certain category. And we'll talk more about that here in a little bit. So make sure you keep the bars pretty close together, or pretty close to the same size. Make sure they're lining up with about where they should be as far as counts. Okay there? All right. A relative frequency bar graph, you don't have to write this part down. When you see relative frequency, what's the only difference? Percentages. So you can create a relative frequency bar graph with that same set of data. The only difference is you would measure the percentages. So first class had 325 out of 2,200 total people. So the percent would be somewhere around, it looks like 15, 16%. Second class had 285 people out of the 2,200, somewhere just above 10% there. So the only thing that changes is our scale on the y-axis. So now we're talking percentages. We have to make sure all percentages are accounted for. And then the label. You can still call it frequency, but you need to denote that you're talking percentages. So frequency alone denotes counts, the total number of people in a category. Frequency with a percent sign after is telling us we're looking at percentages for the data, not counts. Okay, which makes a world of difference as far as how you analyze. Everything else exactly the same. Okay. Pie charts. As far as pie charts go, I don't think we're going to spend a lot of time making them. It's a very involved process. You guys have to make pie charts in the past at all? You have to use a protractor, calculate percentages, degrees, mark the wedges on the circle and all that stuff. So it's a very drawn-out process. It's not something that we're going to ask you to do. The main thing we'd probably ask you to do is be able to look at a pie chart and decide different things about it, or determine if we can use a pie chart or not. Because remember, pie charts can only happen in specific instances. And that instances is when we're dealing with parts of a whole. So a pie chart can only be created when we're talking about parts from a whole, from an entire population. The other thing you'd want to note here, pie charts only work with categorical variables. Okay. So make sure if you're looking at data and they're asking, hey, can we make a pie chart of this? You need to make sure you have all the categories accounted for. You need to make sure that everything is coming from one population and not multiple sets of populations. Okay, so it needs to be coming from one original source. Okay. The other thing, and we're going to start talking about this kind of now, good graphs versus bad graphs. Okay, when you create your graphical displays, you can mislead people very easily with how you display your data. Okay? For instance, the pie chart that I have up here looks pretty, right? It's very visually pleasing. But this is a bad pie chart. Can anybody see anything wrong with the way this data or this is organized that would make this kind of misleading?
Only like the red and the purple that look three-dimensional.
Okay, so they made it kind of three-dimensional, right? People like three-dimensional, and so they kind of have it like it's like a little wedge just sitting on a table or something, right?
The red 28% looks bigger than 90%.
Okay, this red 28 actually looks bigger than, or at least as big as, the 30%, right? Well, we know based on percentages, if this is a bigger percent, then this should be a bigger wedge, right? How does the red 28 compare to the blue 28? It looks like, in my opinion, I think this looks even maybe a little wider than this 28, right? Maybe a little bit bigger. Well, if they're both 28, they should both be the exact same wedge size. So one of the things you want to kind of keep in mind, when people report data to you, they will be very sneaky sometimes. If they want something to look or want to misrepresent information, it's very easy to do. If someone was trying to push for this to get more money or something like that, they could put that at the front of this graph, make it look like it's a huge portion, it's a very important category, and we need more funding for it or something like that. When in actuality, the yellow is probably the one we'd want to push for more, since it's a higher percentage. So people can mislead the way things look very easily within graphs. So you always want to be very careful when you look at those to make sure they're not misrepresenting something with scales, with the perception of the graph, and so on. Like here, the 3 dimensions kind of throws some of those wedges off a little bit. Does that make sense? And we'll talk more about that as we progress, but that's one of the things to kind of keep track of. To make a pie chart, we're not going to do this. Okay, I took this out last year. It's not something I'm going to expect you guys to do at any point. They don't do it on the AP exam. We're not going to worry about making pie charts. If you want to know how to make a pie chart, you can come talk to me outside of class. We'll go through it, but you won't need it. Next thing, some more bad graphs. Pictographs. There are times where people will represent their data with what we call pictographs. It's basically a bar graph, but what's the difference? Yeah, instead of a bar, they just put a picture. So if we're talking about the distribution of classes for the Titanic, we could have used bars, but they decided to use boats, replicas of the Titanic, right? Now, if we look at this display, I said it's a bad display. What makes it bad? What's wrong with this picture, do you think, that makes it something we wouldn't want to use or we wouldn't want to trust as far as information?
It measures this way, but they're different like heights also.
Okay, so in a bar graph, what we should be focused on is what, like the amplitude, the height of the bar, or the number of counts, right? So we should be focusing on how long the ship is, but what do they do to each of these ships? They make them different widths as well, right, or different heights. This, the longer it gets, the wider it gets, correct? Now, compare from here to here, so from crew to second class, how much bigger did the crew class appear to be? If you had to quantify how many times bigger it was, what would you guys think? 5, 6, 7 times bigger, right? Well, if we go back to the actual data, the difference between crew and second class, crew was maybe 3 times bigger. but the fact that they're switching the width as well as the length of the bar misrepresents the size of the different classes. Okay? So you always want to be aware that pictographs almost always are bad examples. Bad graphs because they're going to misrepresent the length of a specific category. The other thing that can definitely throw off perception, something else that people can do really easily that misrepresents data, is work with the scale. So when we create our scales for our bar graphs and later on our histograms and things like that, one of the things we want to make sure that we're doing is we're creating scales that are going to fairly represent the information we're looking at. So we have two bar graphs. Now they show the exact same information. They are the exact same numbers. So here we're at about 1819. Here we're about at 1819. So they're the exact same sets of data. Which one of these would probably be a little misleading though? The one on the right, why? Okay, if we look here, our scale starts at 10, whereas here it starts at 0. Now if we look at this graph here, how much bigger does the none category appear to be than the PC? Yeah, like 3, 4, 5 times bigger, right? When in actuality, how much bigger is it actually? Like less than 2 times bigger, okay? By simply changing the scale 10 units, 10 percentages, they have completely changed the dynamic between the different categories. So you want to be very careful with how you represent things on a scale. Another example, back when I worked at Bellevue, one of the things they came back, one of the things they loved to compare, Bellevue West versus Bellevue East, was ACT scores. Do they do that here, between South and here? A little bit, okay? Well, the one day, they came in and they said, okay, we got a big issue here. Here's Bellevue West score. There's their average ACT. Here's Bellevue East score. Major issue here. Bellevue West killed us on the ACT. Okay, this was the graph they presented to us. Very similar to this. But when we looked at the scale, that was the scale. So Bellevue West scored an average of 21.2, Bellevue East scored an average of 21.1. There was 0.1 difference between the two schools, but notice the way this looks, the way it makes it look compared to the two schools, right? So when you're creating your scales, make sure you're not zooming in too much, because then you get this misrepresentation. It looked like they slaughtered Bellevue East, right? But it was a 0.1 difference as an average. The other thing you want to make sure of, though, is you don't zoom out too far, because then you start missing differences that might actually be occurring. So it's always kind of that idea of finding that middle ground, finding what's going to represent it as fairly as possible, but also for you guys to know, when you are looking at graphical displays, are they misrepresenting data, or are they showing it fairly so that you can make a informed decision? Okay? That's it. I know that was a lot for today. Anytime we have like a lot of vocabulary and stuff like that, I know it takes a little bit longer. I'm hoping that with some of those sections coming up, we'll get you guys some time to work in class. But I want you guys to try these problems out tonight. Okay? For the most part, they should be pretty straightforward. There's like maybe one or two create a bar graph, a couple multiple choice, a couple short answer. On the 12 and 16 here, only do parts B. So only do part B for those two. I don't need anything else from that particular problem. The answer key for this is up on the blog already. So as you're working on it tonight, if you want to check your work, make sure what you're writing down matches what I have, you can do that. Like I said, though, this is your first assignment. This is going to set the tone for the rest of your semester here. Tonight, try to do as much of this as possible. If you can get it completely done, fantastic. If you can't, that's fine, because remember, this won't be turned in until Monday. But realize that tomorrow you're going to be getting another assignment. So if you start getting a huge overlap between assignments, it's going to be very tough to stay caught up throughout. So it's always a good idea to start off right, do as much as you can tonight. Tomorrow, talk about any questions that you guys might have that we can get through. Go through the next section Bingo's.